Good evening, everyone. This is your week 2 recent advances in transmission insulator course. I am your teaching assistant Nida Khanam, research scholar from Department of Electrical Engineering, Aligarh Muslim University. So, from since last session, we have studied introduction of recent advances in transmission insulators, important components, development of transmission voltages, transmission technologies, standard transmission voltages, power intensity level, key components, insulation coordination, history of transmission insulators, and different types of transmission insulators. Okay, now in this presentation, we will be discussing on the field experience in transmission insulators and different their manufacturing process, design criteria, and what will be the pollution and flashover, and the comparison of non-ceramic, ceramic, and glass insulators, their comparative analysis. And finally, we will discuss environmental issue with the transmission insulators. Okay, so first of all, can anybody tell me what is ceramic insulator? Okay, so basically ceramic insulators are those type of insulators which are used to which is built by ceramic or porcelain. Okay, it is used since 1830s for telegraphic lines, and it is used for all the voltages for line insulation. It provides greater flexibility because it's a very traditional and used for all voltages, and it is strong enough and mechanical strength is very high. It is available in various shapes, that is from simple to complicated, and having high degree of standardization. So in this figure, we see that the starting of ceramic insulators in 1880s. Okay. Then when as the voltage level increases, different type of manufacturing companies made their ceramic insulators according to their need. Okay. This is the development of ceramic, or you can say porcelain insulators. Then there were two people that were Edward Howlett and Harlow Buck, who started this for telegraphic lines. Then after that, glass insulators and non-ceramic insulators, which is nowadays being widely used for high voltage transmission lines, are developed. So you can see this is the cross section of ceramic insulators, in which there are one malleable ductile iron cap, and second is malleable forged iron pin, that is the metal pin, and in between these two pin there is a porcelain shell which has different petticoats. Okay, and this shell is integrated using the Portland cement, and after that after that cement bituminous coating is done, and then sand band. This is the cross section area of pin type ceramic insulators. Okay, moving on, how an insulator functions. Basically, the insulator, basically what it does, that it maintains the air gap which is in between the line from the ground, and depends on the system voltage, safety margin, contamination, etc. Contamination, or you can say pollution, or anything. So depends. It depends on mechanical stresses. That means the static, tension, compression, or any dynamic load. Okay, and second is it withstand with electrical stresses, like it depends on system voltage and over voltages. Also it depends on with environmental stresses, like there is ice contamination, or and UV or heat or cold. So all this depends on insulators properties, that is mechanical, electrical, and environmental stresses, or you can say strengths. So there are some factors in which at which the voltage level depends. Depending upon these voltage levels, the factors which are responsible for insulation design, that is from voltage level up to 4 kilovolt, the main factor which is responsible for insulation design is mechanical clearance, and the voltage level from 4 to 34.5, the main factor which is responsible for insulation design is corona and surges, and the voltage level from 69 to 220 kilovolt. The main factors, the factors which depends the insulation level is lightning and switching surges, and extra high voltage and ultra high voltage, that is 345 to 765. The factors, the main factor, it depends on switching surges, contamination or pollution. And above 765 to 1500 kilovolt, the main factors depends on contamination. Okay, so for extra high voltage and ultra high voltage, pollution and contamination performance is very important. So now we will see the manufacturing process of ceramic insulators. So in this ceramic insulator, first of all, we have to take the raw materials like quartz, feldspar, alumina or clay. Okay, then the grinding process occurs. After grinding, they mix all the materials in powder form and proceed to the sieving. Then material suspension and multi-disc sieving and demagnetizing. In demagnetizing section, all the iron particles are removed from that suspension, and 18% of water uh, is vaporized in this process, that is dewatering. And after that, homogeneous mixing and de-airing is done, and then molding shaping is done with the help of plaster of paris, and they will give the required shape of insulators according to their structure. And then drying, glazing, firing, sorting, and after that testing will be done. In testing, we use different type of tests like porosity test, hydraulic pressure test, temperature cycle test, and electrical flashover. And finally we assemble that, and for us after that after assembly, we check the mechanical strength and electrical flashover. These are the overview of manufacturing process of ceramic insulators. In details, I will give some notes on this. Okay. So after ceramic manufacturing process, we proceed on glass suspension insulators. As the name suggests, it is made up of glass. So the main property of glass suspension insulators are it as having a good contamination performance due to its self-cleaning properties. Second is it is good for remote areas with no gun shooting and helicopter patrols, and its outer glass surface under higher tension than inside glass, and it is damage to outer surface causes if there is violent shattering of shell, and spontaneous failures can occur. And it is also attractive to shoot because the shell explodes when hit, and shattered glass is a safety hazard. And but it is not popular in US, but it is used in Europe, Canada and Brazil. You can see the glass insulators made up of glass, and it also has a metal and ductile cap, pin and ductile cap, and it is used in transmission lines like this. So for manufacturing purpose, the different steps also here. As you can see, there first of all we will take the raw materials for glass insulators such as soda ash, feldspar, and minor amounts of other agents, then crushed to powder, then screened, measured and put in storage towers. Then this mixture is fed to the electric furnace, and which undergoes melting phase and then fining phase. And glass is drawn at a rate dependent on heat input and input feed of raw materials, that is molten glass is at 1400 degrees Celsius. So at exact temperature, glass drops into a cast iron mold and immediately pass to shape. And molded shell is transferred to heat tempering followed by thermal shock, where shells are dropped into water. Now shells not tempered properly or contains defects are all the defects are collected and are inspected, and after that alumina is cemented over it and insulators are proof tested mechanically. So for this purpose, various conformance tests are performed according to the applicable NC or IEC or IEEE or national standards, and it is created for shipment. So this is the process of manufacturing of glass insulators. After that, we see the steps of manufacturing the glass. Here you can see we will take the raw materials, then screening, then we send it to the furnace for firing, then melt it, uh, and we mold it into according to glass shape by use of plaster of Paris, and then we dewatering it and perform the test, final packaged it. Okay, this is the cross section of the glass insulators, in which we see that this is a pin that is forged steel hot dip galvanized, and cap is a malleable iron hot dip galvanized. Between that we use toughened glass shell. Okay, and aluminous cement and bituminous layer also there, which we saw in ceramic insulators. And this is the overall process and cross section area of glass insulators. Now, moving on, these two insulators are traditional, but nowadays the non-ceramic, that is the polymer insulators, are being used. That is the mixture of two insulators, and it's a development of composite or polymeric, or you can say silicon rubber insulators. The first polymers used for electrical insulation were bisphenol and cycloalphabetic epoxy resins, which is introduced in mid 1940s, and CE, that is epoxy, were introduced in 1957 for outdoor insulation in 1963, and in England, France. And in Germany, units of field testing were done in 1967, and in early 1970s, manufacturers introduced first generation of commercial polymeric transmission insulators. This table 1 shows the history and the first generation commercial polymeric transmission line insulators developed by different companies and in different year, and which were being used for different countries. Here you can see the company name, which produces the commercial polymeric line insulators. So basically, it is introduced in 1970s for transmission and used for all the voltages. The main properties of non-ceramic insulator is it is very lightweight, flexible, high strength to weight ratio, and strong in tension. So it is a low degree of standardizations. This is the cross section of non-ceramic insulators, in which we see the fiber glass core, and it is end fitting rings, and these are the weather shades. Okay, now you see, if you see this figure, then these are the end fittings with the that are zinc coated using the heat method. Then in this rod shows the fiberglass core, or fiberglass. Okay, this is the high reliability of the end fittings specializations is done by here, and non-ceramic insulators is the most popular and widely used for high voltage transmission lines nowadays. So
Excuse me, ma'am. Still the slide is in the 10th slide only, ma'am. It shows in video. It is the 10th slide only. Yeah. And now it is okay, ma'am. Non-ceramic insulator. Slide number 13 now. Yes.
yeah,
Yeah.
okay. Have you seen this slide?
No, ma'am. No, ma'am. No, ma'am. You explained, but
Okay,
in
okay.
10th slide it's stuck on.
Now
Yes.
manufacturing process of
Yes, yes. It is okay. It's okay.
okay. It is 10 slide, and after that it's cross section area and manufacturing process in flowchart form. Uh, this
No,
slide.
ma'am. Now again. Ah,
Okay,
now okay. Now okay.
okay, okay. So this is the manufacturing process of glass insulators, in which you see the steps in manufacturing of glass insulators, we take the raw materials, then mix the powder in, and after that is screening, and send it to the furnace, and melting process are done, and after finalizing all the methods, then we test and packaged it. Okay, this is the cross section area of glass insulators, in which the ductile malleable iron hot dip galvanized cap here, and here is a metal pin which is forged steel, and the in between that there is a toughened glass which is made up of the glass insulator is made up of toughened glass, and and over here aluminous cement and bituminous layer is here. Okay, this is the cross section, you can say, diagram of glass insulators. And now we proceed to the non-ceramic insulators. Is it visible, non-ceramic? Okay.
Yes, ma'am. Yes.
Okay, so basically, after polymeric and glass insulators, we move on to the non-ceramic insulators. It is the composite insulators made up of silicon rubber. And first polymers used for electrical insulation were bisphenol and cycloaliphatic epoxy resins, which is introduced in mid 1940s. But when cycloaliphatic epoxies were introduced in 1957 for outdoor insulation in 1963, and in Germany, units of field testing were done in 1967. After that, in early 1970s, manufacturers introduced first generation of commercial polymeric transmission insulators. Here you can see the table in which different company produces their polymeric insulators with the housing materials used here and in different years, and which were being used by the different countries like France, USA, Germany, England, etc. Okay, EPR is here ethylene propylene and rubber, and SR is silicon rubber. Mainly the main material which are being used for the non ceramic insulators is silicon rubber or epoxy or cycloaliphatic epoxies. Okay, so this is the cross section of the non ceramic insulator. Basically, it is introduced in 1970s for transmission purpose and used for all voltages. The main advantage of non-ceramic insulators over glass and ceramic insulators is that it is contaminated. It is very light in weight, high tensile, high strength to weight ratio, and strong in tension. And but it is having the low degree of standardizations. And this is the cross section of the pin type non-ceramic type insulators, in which we see the fiber glass core, and these are the weather shades, and these are end fitted with the end fittings, and which is the high reliabilities of the end fittings pressurizations. And this is also the cross section of the end non-ceramic insulators. Now, the main manufacturing process of non-ceramic insulators is that stages. First of all, raw materials. We use the raw materials such as silicon rubber, FRP rods, metals, and fittings. Then after that, we pass the ultrasonic. We use the ultrasonic cleaning process. Metal fittings are dipped into a liquid for 15 minutes and are free from any kind of impurities present over the surface. Okay, then there is a end metal fitting, crimping or swagging. Then step by step process of crimping method is that selection of the material. We select the appropriate cleaned metal fittings, then component settings, jaw setting, initial zero setting. These are the settings which we are doing for end metal fitting. Then after that, we perform the surface preparation. The surface of FRP rods is made smooth. The coating of diluted primer chemlock is 608, that is the 20% diluted, is applied so that shades or housing are properly attached to FRP rod surface. And the coating also helps to maintain high hydrophobicity so that there is no erosion or surface flashover takes place. And after that, injection molding is done. It is suitable mold is the selected for injection molding is at 160 degree, and molding is done in three stages. So first of all, bed of machine is cleaned by using valve lapping compound, and later by a jet or of a compressed air. Then curing process is done so that it becomes hard. Rods are now housed using silicon rubber by using this process, and generally alternate type of shades is preferred because in case of the rain, the continuous stream of water is discretized into droplets, reducing the frequency of the flashover. Then sixth step is deflashing, that is the insulator is placed on the racks or stacked in the wooden supports, and after the component has cooled to ambient temperature, the sticking extra flash material is removed manually or by knife. So in case of traction insulators, three types of deflashing is done. First of all, bracket insulator for inclined purposes. Second is 9-tone insulator to be used for maintaining horizontal, and stray arm insulator to be used for horizontal purposes. So after this main process, we do the routine test. Routine tests are performed during the production process prior to crating and shipment, and this test will eliminate defective insulators which might otherwise fail immediately upon installation and energization. And then mechanical, electrical, and bending tests are performed. So this is the flowchart of manufacturing process of non-ceramic insulators, in which we collect the silicon or FRP rods or metal and fittings or raw materials. Then metal fitting cleaning is done. Then crimping, primer coating, injection molding. These are the main things of the end fittings. Then we do the deflashing, then testing, and after testing for this is in the hardness tester, and finally the non-ceramic insulator is ready. So now we moving on to the design criteria. What are the main design criteria for making an insulator? So we check for the mechanical test, electrical test, and environmental test. So insulator primary function is to support the line mechanically. So it is required to estimate maximum load that insulator will ever see, including normal and overload conditions. So in mechanical design criteria, we see the two main properties, that is the tensile strength and compressive strength. And according to different type of insulators, tensile strengths are different. And if you see the tensile strength of porcelain, it is 30 to 100, and for glass it is 100 to 120, and for polymer it is very low, that is 20 to 35. And the second is compressive strength. For porcelain it is 240 to 820, and for glass 210 to 300, and for this type of polymer 80 to 170. So now there is the design criteria based on electrical properties. So we see the dry arcing distance. The dry arcing distance is the distance between the from this end to this end, the shortest distance to the surrounding medium between the terminal electrodes. Terminal electrodes, we are saying this type of electrodes at which the terminals ends. Okay, so we do based on the dry PF flashover and impulse flashover, we see the strike distance, and leakage distance helps to maintain the surface resistance of a strike distance. Okay, so this distance is known as dry arcing distance for design criteria in electrical. So now we see the field experience with insulators. As we all know that insulators play a very crucial role in power transmission and distribution by providing electrical isolation, and provides mechanical support to conductors. Field experience with ceramic, glass, and polymer insulators has have revealed important performance trends, advantages, and challenges under different environmental and operational conditions. So first of all, we take the ceramic insulators. As we know that ceramic or porcelain insulators have been used in power system for decades due to their excellent electrical and mechanical properties, and they were widely deployed in transmission and distribution networks, especially in regions with extreme weather conditions. Its a performance in term of field experience and service experience is there are four characteristics. That is, it is very durable. Like ceramic insulators have a long service life, typically 40 to 50 years, and are resistant to ultraviolet radiations. Second is pollution resistance. So as we know that in industrial and coastal areas, ceramic insulators tend to accumulate pollution, which can lead to flashovers. Now, third is thermal stability. Ceramic insulators perform very well under varying temperatures, but can experience thermal stress leading to cracks. Now, the last is mechanical strength. So, ceramic insulators provides high mechanical strength, which ensures the reliability under extreme weather conditions such as heavy winds and ice loads. But there are some challenges which experiences ceramic insulators in field, like when pollution and flashover occurs. So in highly polluted environments, ceramic insulators require frequent washing or silicone coatings to prevent contamination flashover. Second is cracking and chipping. So over time, mechanical stress and thermal cycling can cause ceramic insulators to crack, leading to partial discharge and insulation failure. And third is heavy weight. Their weight makes installation and maintenance more challenging, especially in high voltage applications. So here you see the ceramic insulators. Here you see that ceramic insulators installed on power grids and have been subjected to widely varying temperatures for decades. But as the climate change accelerates, the severity of weather patterns, droughts, and wildfires is increasing. And because of this, exposing lines and their insulators to growing environmental stresses. So, this can cause the damage of insulators. Now you see here that this is the porcelain housing with shattered sheds from extreme heat of power arc. And this is the due to the mechanical stress, it breaks down. Okay, now moving on to the glass insulators. Glass insulators are made from toughened glass or and have been extensively used in high voltage transmission systems. They are known for their self cleaning properties and resistance to environmental degradation. Okay, the main performance of glass insulators is having the self healing property. Like when glass insulators break, they shatter completely, and it prevents the partial failures and reducing the risk of hidden defects. Second is high transparency and UV resistance. The glass insulators do not degrade under.
Your voice is not audible, I think.
Okay, glass insulators are made from toughened glass and have been extensively used in high voltage transmission systems. They are known for their self cleaning properties and resistance to environmental degradation. So they are having the different performance skills, like it is having the self healing property. Like when glass insulators break, they shatter completely. It prevents partial failures and reducing the risk of hidden defects. Second is high transparency and UV resistance. The glass insulators do not degrade under prolonged exposure to sunlight and UV radiation. Now, third is superior hydrophobicity, means glass insulators are less prone to pollution related flashovers as compared to ceramic insulators. So, these are the advantages over ceramic insulators of glass insulators. So you can see here, these are the glass insulators, uh, and these are in transmission lines, how they are put in transmission lines. Okay, now field experience with glass insulator is that its brittleness property, like although toughened glass is very strong, but it is more susceptible to mechanical impact damage during transportation and installation. They can break. Okay. Second is ice and snow accumulation. So as we see that in cold climates, glass insulators can experience ice built up, which may lead to mechanical stress and failure. And third is high initial cost. As compared to ceramic insulators, the initial cost of glass insulators is very high, although they require less maintenance. So now we see the field experience with the non-ceramic insulators. As we know that polymer insulators made up of fiber reinforced rods with silicon rubber, or you can see and EPDM, that is ethylene propylene diene monomer. They are lightweight, flexible, and resistant to environmental pollutions. And the main property of polymer insulators are pollution and hydrophobicity. That is, the silicon rubber housing provides excellent pollution resistance by repelling water and contaminants, and it reduces the risk of flashovers. Second is lightweight and easy installations. Their low weight makes them easy to transport and install, especially in remote locations. Third is flexibility and vibration resistance. As we know that polymer insulators perform very well under mechanical stresses, and including wind induced vibrations and seismic conditions. So these are the properties of polymer insulators. But here you can see the cross section of the polymer insulators. That is, there are two end fittings, that is at energized pin end, and this is the tower end. And now this shows the fiber orientation, rubber housing, and GRP composite rod is in between them. This is the different diagram of polymer insulators in different shapes. So when there are many challenges in field, like having the property of aging and degradation. So over time, polymer insulators experience aging due to UV exposure, high temperature, and pollution, leading to surface degradation and cracking. Second is mechanical failures. Some polymer insulators have failed due to their brittle fractures in the fiberglass core, which can lead to sudden mechanical collapse. Third is lack of standardized testing. That is, the when compared to the ceramic and glass insulators, field data on long-term performance varies, and making reliability assessment more challenging in polymer insulators. Now we see the pollution and flashover. So pollution is the one of the major concern for insulator performance in real world conditions, and contaminants like dust, salt, and industrial pollutants accumulate on the insulator surface, and forming a conductive layer when mixed with the moisture, and this can lead to dry band arcing and flashover. Then what is dry band arcing? Dry band arcing is the partial discharge caused by uneven wetting of the insulator surface, because when the salt or any other pollutants accumulate on the layer of the surface of the insulators, it becomes conductive. So when comes into the moisture, then it becomes conductive. So this is known as dry band arcing, that is partial discharge caused by uneven wetting. Second is flashover, that is a complete breakdown of insulation leading to power outages. So after flashover, the insulators will out of work. Okay, now the main solutions for pollution management is that we will do silicon coating. Like if we use ceramic or glass insulators, so we do the silicon coating on that. So to enhance the hydrophobicity. Second is leave line washing, that is a periodic cleaning with pressurized water, so that the contaminants that is deposit on the layer of that insulator will remove. And third is polymer insulators, so their natural hydrophobicity helps in polluted environments. These are the solutions which can be used for the uh, insulators. So there are comparison of non-ceramic, ceramic and glass insulators in terms of features like material, weight, mechanical strength, contamination resistance, shatter resistance, aging resistance, installation, ease and cost. So first of all, non-ceramic insulators, the main material used for non-ceramic is are polymer and fiberglass. Okay, and for ceramic insulator we use porcelain, and for glass insulators we know toughened glass is used. And for the as for talking about the weight, the non-ceramic insulators is light in weight, but ceramic and glass insulators are heavy as compared to non-ceramic. Now third is mechanical strength. The mechanical strength of non-ceramic insulators is very high, but in both the case ceramic and glass they are moderate. Fourth is contamination resistance. This property is very excellent in non-ceramic. That's why it is used for high voltage transmission lines. But ceramic insulators, it is moderate, and in glass insulators, good. Now, shatter resistance, aging resistance, moderate. UV can Ultraviolet radiation can degrade the properties of non-ceramic insulators, but aging resistance is very high in ceramic and glass very high. Okay, installation is very easy in non-ceramic insulators, but for ceramic and glass it is very difficult. Cost is also very high for non-ceramic, that is polymer insulator, but lower cost for ceramic and moderate for glass insulators. So this is the comparative analysis of non-ceramic, that is polymer, ceramic, porcelain, and glass insulators. So there are some environmental issues with the transmission insulators. As we know that transmission insulators are a crucial component in power grids. It provides the electrical isolation as well as mechanical support to conductors. However, various environmental factors impact their performance, leading to failures, reduced lifespan, and increased maintenance requirements. So some of the major environmental issues that affects the transmission insulators are, first of all, we know pollution and contamination issues. So as the industries and urban pollution, transmission insulators in industrial areas accumulate pollutants such as smoke, dust, chemical residues, and conductive contaminants like all the carbon particles and metal oxide. These all are increasing leakage currents. That's why insulation failure occurs in transmission. Second is coastal and marine pollution. So in that type of pollution, salt deposits from ocean air from conductive layers on insulators, leading to salt fog flashovers. Next is the high humidity in coastal area, as we know. So that worsens the contamination, making frequent cleaning necessary. Okay, third is agricultural and desert pollutions. So on this type of pollution criteria, the dust, fertilizers, and pesticides settle on insulators, which reduces their insulation capacity. And dry and dusty environments lead to dry band arcing, which can cause insulation failures. So the main solution for this is we use hydrophobic coatings on insulators, that is for example silicon rubber coatings. And second is live line washing of insulators in highly polluted regions. Third is we can use polymer insulators that naturally repel contaminants. Okay. The next environmental issue is flashover due to wet and humid conditions. So as we know that in humid conditions, pollutants on insulators become conductive when mixed with the moistures, so leading to flashovers. And second is water droplets on insulators create uneven surface conductivity, causing localized discharge known as dry band arcing. And third is high altitude areas with frequent fog and mist that increase the risk of insulation breakdown. So the solution for this is we use the hydrophobic polymer insulators which resist the moisture buildup. And second is application of RTV. RTV is room temperature vulcanizing silicon coatings on ceramic and glass insulators. So the third environmental effect is impact of extreme weather conditions. So in this impact, we see the lightning strikes and over voltages, and second is temperature variations. So in lightning strikes, it can damage the insulators by causing punctures, fractures, or carbonizations of the surface. And second is switching surges and transient over voltages that stress the insulation and reduces the service life. Now, if we see in the cold region, ice acceleration increases mechanical stress on insulators and leading to its breakdown. And in desert areas, high temperature accelerate material degradation and particularly in polymer insulators. So the main solution for this, we use the arcing horns and surge arresters to protect the insulators from lightning damage. And we use heat resistant material for polymer insulators in hot climates and hydrophobic coating to reduce the ice accumulation. Now, the fourth environmental factors is ultraviolet degradations. Ultraviolet degradation, mainly popular and main exposure of UV is done in polymer insulators, which causes the surface cracking and loss of hydrophobicity. And it is prolonged UV exposure leads to chalky deposits, reducing insulation performance. So the main solution for this is that we use the UV resistant polymer insulator, that is silicon rubber with UV stabilizers we can use here. And we use ceramic or glass insulators in areas with where extreme UV exposures are there. Then we can use their glass or ceramic instead of polymer insulators. Now, the fifth biological and environmental attacks are bird-related issues. Like many of people can see that birds nesting near transmission lines. It can cause contamination from droppings, leading to bird-induced flashovers. And large birds landing on insulators can cause mechanical damage. And the second is fungal and algae growth. So in tropical regions, we see the biological growth like fungi, algae, and moss accumulates on the insulator surfaces and leading to increased leakage currents. So the solution for that is that bird guards or deterrent devices to prevent nesting near insulators, and we can use antifungal coatings or regular maintenance in humid climates. So the sixth factor is aging and environmental degradation. So over time, ceramic insulators develops cracks and glaze deterioration, affecting their insulation properties. And the second is polymer insulators suffer from erosion and tracking, especially in polluted and high voltage applications. And glass insulators are prone to mechanical damage due to temperature variations and other impact, like for installing and for supporting them in the ice coated area. So the main solution for this, we can regular condition monitoring and infrared thermography to detect early signs of insulation failure, or we can replace the aged insulators with newer one, or we can use the pollution resistant alternatives. So based on this presentation, in which I have shown you different types of insulators like ceramic, glass, and polymer insulators, their properties, their field experience with the different challenges, manufacturing process, design criteria, and environmental issues, and what will be their solutions, comparative analysis of different type of insulators. So based on these presentation, are you ready for objective questions? Give the answer for objective questions based on this presentation and previous one. Okay.
Yes.
Okay, so the first question is, which type of transmission insulator is most affected by UV radiation over time?
Polymer insulators.
Okay. So instead of polymer insulators, we can use their ceramic insulators and glass insulators. Okay, answer C is correct. Polymer insulators. Now the next question is, what is the primary advantage of glass insulators over ceramic insulators?
Self-cleaning property due to smooth surface.
Yes. Anyone else? What would be the answer? Okay. The main advantage of using the glass insulator is self-cleaning property due to their smooth surface over ceramic insulators. So the third question is, which of the following environmental factors has the most severe impact on polymer insulators? Acid rain, UV degradation, ice and snow accumulation, wind pressure.
Acid rain.
Anyone else? Most severe impact on polymer insulators.
B.
Hmm?
UV degradation.
UV radiation. Anyone else? No. Mohana, Sabasini, are you there? Okay, it's a UV radiation, that is the severe impact on polymer insulators caused by ultraviolet degradation. So fourth question is, what is the major cause of flashover in polluted environments? Major cause of flashover.
Dry band arcing.
Anyone else? Only two people are giving answer. Where are you all? Only join and leave. Okay. It's a dry band arcing. It is the major cause of flashover in polluted environments. Now, the fifth question is, what type of pollution has the most significant impact on insulator performance in coastal areas? Dust
Salt
pollution.
contamination.
Okay, sir. Sir, dust pollution, industrial pollution, salt contamination, and biological growth. Yes, Priya.
Industrial pollution.
Industrial pollution. And anyone else?
Dust pollution.
Dust pollution. Any other? Lavanya, Mohana. Okay. The correct answer is salt contamination. Salt contamination has the most significant impact on insulator performance in coastal areas. Uh, Coastal areas. Okay. You can see here coastal and marine pollution. Salt deposits from ocean air from conductive layers on insulators, leading to salt, fog, flashovers. Okay. So the next question is, which insulator type is most resistant to salt, fog, and high humidity environments? Ceramic insulators, glass insulators, polymer insulators, both B and C. Sorry,
Polymer insulator.
polymer insulators. Any other? Karthik sir?
Answer B and D.
D.
D, both B and C.
Okay. Anyone else? Karthik sir?
Sir, both
Answer?
B and C.
Both B and C. Okay. Any other? Okay. The right answer is D. That is both B and C. Like glass insulators and polymer insulators. Both are most resistant type of insulators to salt, fog, and high humidity environments. So the next question is, what is a common failure mechanism observed in aged ceramic insulators? इसका answer given actually. Okay, it's a cracking and glaze deterioration. It is a common failure mechanism which is observed in aged ceramic insulators. Okay. Question number 8 is, what is the primary reason for using polymer insulators in polluted areas? Option A, lightweight and ease of handling. Second, better self-cleaning ability. C option is high mechanical strength. D is low production cost. Primary reason for using polymer insulators in polluted areas.
So lightweight and easy of handling.
Better self-cleaning ability.
Okay, any other?
Low production cost.
Low production cost. Any other? Okay. Who said self-cleaning ability?
Yes.
Okay. Actually, sir, self-cleaning property is the property of glass insulators. Hmm? We have discussed.
Okay.
The correct option is lightweight and ease of handling. This is the main property for polymer insulators.
Ma'am, can I ask one doubt, ma'am?
Yes.
During the pollution property of the polymer insulator we discussed, periodically we have to clean the insulator, like that you told me. But for a transmission and distribution line, whether it is possible for several kilometers of line?
We can use their uh, for several kilometer lines. We can use the high pressure water for cleaning purpose. If we use their ceramic insulators, then we can use their high pressurized water for cleaning purpose. Or I discussed earlier the solutions.
Yes, madam. Yes, in your slide it is like that only. I am asking whether it is possible for a several kilometer of distribution and transmission lines.
Yes, it is possible.
Okay, okay. So we have to shut down the line, and then we have to clean.
Yes,
Correct,
yes,
ma'am?
yes, yes, yes.
Okay, okay.
Okay. Now moving on to the next question. Which environmental condition primarily causes mechanical damage to glass insulators? First is acid rain, second is extreme temperature variation, third is industrial contamination, fourth is bird droppings.
Extreme temperature variations.
Okay, anyone else? Priya, Prabhasini? Okay, okay. Priya, are you giving answer?
Um, Industrial contamination.
Industrial contaminations. Okay, anyone else?
Temperature variations.
Extreme temperature variations. Okay, so
Yes.
for the glass insulators, the main condition which primarily causes mechanical damage is extreme temperature variations. Due to that, glass will shatter. Okay, so the option B is correct. The next question is, what type of coating is used to improve the pollution performance of ceramic insulators? First is RTV, silicon coating, polyethylene coating, porcelain enamel, and fourth is epoxy resin coating.
RTV silicone coating.
Okay.
RTV, RTV coating.
Okay, anyone else? And what was the full form of RTV?
Room temperature vulcanized.
Room temperature vulcanizing. Okay. Okay. Um, this is question number 10. Now, question number 11 is, how does industrial pollution affect insulators in urban areas? How does industrial pollution affect insulators in urban areas? First is increase leakage currents. Second is decreases mechanical strength. Third is prevents flashovers. Fourth is enhances insulation resistance.
Increases leakage currents.
Okay, anyone else? Increases leakage currents, decreases mechanical strength, prevents flashovers, and enhances insulation resistance.
Increases leakage currents.
Okay, this is the correct answer, increases leakage currents. Now, the question number 12 is, what is the major advantage of using polymer insulators over ceramic and glass insulators? What is the major advantage? Why we are using it? So option A is lower weight and better handling. B is high mechanical strength. Third is longer lifespan. Fourth is lower cost.
Lower weight and better handling.
Lower weight and better handling.
Lower
Anyone
weight
else?
and better handling.
Okay. Anyone else? Okay, the correct option is A, that is lower weight and better handling. This is the major advantage of using polymer insulators. Why we are using it? Because of its lightweight and better handling capability. Okay, now the third question is known to you, that is what is the primary factor causing the aging of polymer insulators?
UV radiation.
Okay. I think it is repeated. Now the last question is what is the best insulator choice for areas with high industrial pollutions? What is the best insulator choice for areas with high industrial pollution? Option A is porcelain, second is glass, C is polymer, and D is any insulator with RTV silicon coating.
With
Any
silicone.
insulator with RTV silicone coating.
Any insulators with RTV silicon coating. Anyone else?
Choice D, ma'am.
D. Okay. Okay, the correct answer is D, that is any insulators with RTV silicon coating. This is for high industrial pollution. Okay, so now done for today. We have discussed several type of insulators, field experience, manufacturing process, design criteria, and environmental effects. So, okay, this video will upload on the YouTube soon. Now we will meet you on week 3rd, that is on 9th of February, same time. Okay. Till then, if you have any query, then ask me.